Hi everyone. Note 6.4 are on laws of logarithms. So the first thing we're going to do is we're going to determine an equivalent expression for log base a of m times n, where a, m, and n are positive numbers, okay? And a is not equal to 1. We don't want to have a base of 1 because a base of 1, it really doesn't really do much for us because 1 to the power of anything will always just be 1, okay? So in questions 1, 2, and 3, before I actually address number 1 specifically, we're going to develop our laws of logarithms, okay? And then once we develop our laws of logarithms, we're going to apply these laws to the next couple of questions that we have, okay? So if you notice right here, question number 1 says to determine an equivalent expression for log base a of m times n. So the first thing I'm going to do right here is I'm going to define m as a to the power of x. And then I'm also going to let n equal a to the power of y. And since inside of here we've got m times n, we can say right here that m times n is equal to a to the power of x times a to the power of y. But we know that a to the power of x times a to the power of y, when we multiply, we need to add our exponents. So we get a to the power of x plus y, okay? So based on that, we're going to now say that this is equal to log base a of a to the power of x plus y. Okay, I haven't really changed anything. I'm just substituting in what we let m and n be, and we just did our multiplication right here. Okay, all right, so now that we've done that, if you remember, our properties from our last video tell us that if we have log base b of b to the power of something, it's just whatever that exponent is right here. Okay, so right here, this is essentially just going to be x plus y. Okay, so now what I want to do is I want to take this piece right here and rewrite this in terms of x. So I'm going to get the x alone. So if I know m is equal to a to the power of x, then I can say that x is equal to log base a of m. So here I can just say this is equal to log base a of m. Okay, plus right here I can say that this is equal to, for this right here I need to isolate the y because I want an equation in terms of y. So y is equal to log base a of n. So I can say here that this is log base a of n. Okay, so therefore I can conclude one of my laws is that if I have two things being multiplied together and it's log base a of that product, it's equal to log base a of m plus log base a of n. So this is one of our really important properties right here. So make sure that you put some like stars around it or highlight it or something so you remember that that's an important property that we have. Okay? All right, so now we're going to determine an equivalent expression for log base a of m divided by n. So we're going to do the same exact idea here, okay? So if I want to do this right here, I'm going to say log base a of m divided by n. And I'm going to let my statements be the exact same statements that we had before. So I'm going to let m equal a to the power of x, okay? And I'm going to let n equal a to the power of y. But this time I'm not multiplying, it's not a product, it's a quotient, I'm dividing. So if I want to divide m by n right here, so m divided by n, that's going to equal a to the power of x divided by a to the power of y. okay? And if you remember, if we have a to the power of x divided by a to the power of y, any division right here, we always end up getting a to the power of, we have to subtract our exponents whenever we're dividing. So it's a to the power of x minus y. Okay, so here what this ends up being is log base a of a to the power of x minus y. Now we have the same base right here, so we can simplify this and just simply say that this is just x minus y right here. Okay, so let's go ahead and rewrite this equation right here in terms of x. So x is going to be equal to log base a of m. So right here, this is equal to log base a of m. And then minus right here, this, if I were to isolate the y here, it would be y is equal to log base a of n. So this is log base a of n. Okay, so we have a second property right here, or a second law, where log base a of a quotient is equal to log base a of the numerator minus log base a of the denominator. So here is our second property, or our second law of logarithms. All right, so question 3 says to determine an equivalent expression for log base a of m to the power of n, where a, m, and n are positive numbers and a is not equal to 1. So just like we did before, we're going to let m equal a to the power of x. Okay, but what we have inside of here is m to the power of n. So what this means here is I'm going to take a to the power of x and raise that to the power of n right here. Okay, so once I do that, just remember that if you have a power to a power, you need to multiply these exponents. Okay, so if you have a power to a power, you get a to the power of x times n, or we could just say a to the power of n times x. It does not matter what order you put it in. I'm going to put it in this order just to see things a little bit more clearly for what we're going to do next, okay? So I'm going to say log base a of m to the power of n is just a to the power of nx, okay? So since we have the same bases here, I end up just simply getting n times x right here. So I end up getting n times x. But what I want to do here is I'm going to rewrite this equation in terms of x. So we know that x is equal to log base a of m. So this right here means that we end up getting n times log base a of m. Okay, so here we can say that our third property, or our third law, is that log base a of m to the power of n is going to equal the exponent that we have here times the log base a of m. Okay? All right, so for number 4, it asks us to simplify each logarithmic expression. So just a reminder that log base a of m times n is equal to log base a of m plus log base a of n. Okay. We also know that log base a of m divided by n is going to be log base a of m minus log base a of n. And then lastly, we also know that log base a of m to the power of n is equal to the exponent times log base a of m. So let's take a look at question A. So here A, it says simplify each logarithmic expression. So here we have the same base of 3, and this rule only works if they have the same base, okay? So we can say that log base 3 of 6 plus log base 3 of 4.5 is equal to log base 3 of 6 times 4.5. So then that turns into log base 3 of, when I multiply 6 by 4.5, 6 times 4 is 24, and then 6 times a half is 3. So altogether that would be 27. So now I need to know what is the exponent. 3 to the power of what will give me 27. So that means that my final answer here is just 3. Okay? All right, so for B, this time we have the same base and we've got subtraction, so that means that we need to divide. So here I'm going to say log base 2 of 48 minus log base 2 of 3 is log base 2 of 48 divided by 3 altogether. And when I do the division, it means that the 48 and the 3 are both what I'm doing the log of. It is not the same thing as log base 2 of 48 over log base 2 of 3. This is not the same thing that we have here, okay? So this is log base 2 of 16 because 48 divided by 3 is 16. So I want to know 2 to the power of what is going to be 16? Well, I know 2 to the power of 4 is 16, so 4 is my final answer for this question right here. All right, and now for question C, it says log base 5 of the cube root of 25. So what I'm going to do is I'm going to rewrite this right here as, I'm going to say this is equal to log base 5 of 25 raised to the power of 1/3. Okay, and using this right here, we know that if we have an exponent here, it can go in front. So I can say this is equal to 1/3 times log base 5 of 25. Okay, now that I've done that, I can evaluate log base 5 of 25, and we know that that is 2. So it's 1/3 times 2. So my final answer here would be 2/3. Okay. And if you look back at our previous notes that we have done, we have an example somewhere around here. Yes, on this page right here, we had 5 to the power of, or log base 5 of the cube root of 25. We did it in a slightly different way and we still get the same answer. So that kind of shows you how the laws of logarithms are connected to what we know about exponentials. Okay? All right, so question number 5 says, express log base 2 of 4x squared over the square root of y in terms of log base 2 of x and log base 2 of y. Okay, and we're going to use all of our properties that we know up here. So the first thing I'm going to do is I'm going to see, oh, I've got some multiplication here. And I've got some division. So remember with multiplication, it splits it up into addition. And with division, it splits it up into subtraction. So I can say that this is the same thing as log base 2 of 4 plus, because we've got multiplication here, we can split it up into addition, log base 2 of x squared, okay, minus, because we've got division here, log base 2 of the square root of y. Okay, so now that I've done that, I can say this right here, log base 2 of 4 is simply 2. And then I can bring this 2 out in front right here because it is an exponent. I can bring it out in front. So I can say plus 2 log base 2 of x. And now I have it in terms of log base 2 of x. And we know that y to the power, or the square root of y means y to the power of 1/2. So we can bring this 1/2 in front. So we can say minus 1/2 log base 2 of y. And this is our answer for what this is saying. And this will prove to be very useful when we go through and start solving some logarithmic equations, okay? And exponential equations as well. All right, so lastly, we just need to talk about what the change of base formula is. So if I have log base A of C, essentially all this is saying is it's just log base, and you can use any other base that you want. So log base B of C over log base B of A. Okay, so using this change of base formula, I want to go back and take a look at a question that we did 2 pages previously. Question number 3, 2 pages previously, so this would be on page 5, please. For question number 3, it says determine the approximate value of log base 5 of 47. Well, all I need to do here is I need to rewrite this using the change of base formula. So first of all, if I just ask you to evaluate log of 100, the answer is 2. And the reason why the answer is 2 is because this has an invisible base of 10. So 10 to the power of 2 is 100. So if we ever use just log without a base, it just means that the base is always going to be 10. Okay? So if I were to look at this right here, I can just say instead that this is equal to log base using the change of log, using the formula we just talked about. I can say this is log of 47 over log of 5. Sorry, I don't know why this is not writing great. And when I do this right here, I can see that when I type that into my calculator, if I take 47 and do the log of it, divide it by 5, and do the log of that, I get this 2.3922, so on and so forth number, which is the same number that we got here. So that'll get us the answer that we need immediately. Okay, so the change of base formula says that we can just do log base of anything of this number right here divided by log with using the same base of our base right here, and we'll get the same answer. Okay, all right, that's it for our note 6.4. If you have any questions, write them down and let me know, and I'd be more than happy to help you out. And that's it. Have a great day.